Story time. Your company's flash sale just dropped, and 10,000 people hit the buy button in the same minute. Your external shipping APIs are returning 429 errors. Your warehouse database is overloaded, and your SREs are coming apart at the seams. The same Shopify webhook has also fired 8 times, and many customers are getting charged twice. It goes without saying, you just lost a bunch of money, and your brand took a hit. 4 problems, 4 tools. Throttle, Concurrency, Debounce, Idempotency. Let's talk about when to reach for each. Okay, here's the function. 4 steps. We have check inventory, we have reserve stock, create shipping label, and send confirmation. Now, on a quiet Tuesday afternoon, everything's going to work fine. But when your flash sale drops, 10,000 order created events fire in the exact same minute. So watch what breaks. 1. The shipping API returns 429s. They cap us at 80 requests per minute. We just sent 10,000. 2. The warehouse database connection pool is exhausted. 10,000 parallel writes hitting the exact same warehouse ID. 3. Shopify sends the same update order webhook 8 times in 30 seconds. We're running the same function 8 times for just 1 order. 4. At least once delivery means we just ran the entire pipeline twice for the same payment. A customer got charged twice. Traditionally, if you wanted to handle all 4 of these, you wouldn't be writing just one function. You'd be writing 4. A throttle queue, a concurrency limiter, a debounce buffer, and a custom idempotency cache. All of this across multiple files with different libraries doing different jobs, glued together by a queue that you have to maintain yourself. And that's hundreds of lines of plumbing. All of that for what is, in reality, 4 lines of intent. Let's look at those 4 lines. Your shipping API returns 429s once you exceed 80 requests per minute. Your function isn't the problem. The rate is. So we throttle it. We limit it to 80 executions per minute by carrier, keyed by that specific carrier. So UPS is going to get 80, FedEx is going to get 80. If 10,000 orders fire all at once, the platform queues the rest and releases them at 80 per minute. No more 429s, no more retry storms, no more back off math. What you've stopped building is the queue, the worker, the exponential back off, the dashboard to watch all of it. 1 line of config replaces all of that. Your warehouse database has a connection pool. 10,000 functions hitting at once doesn't get rate limited. It gets exhausted. Everything backs up and the database starts to drop requests. So we cap how many runs we can run in parallel. We limit to 10 executions keyed by a warehouse ID. So warehouse A can have 10 in flight, warehouse B can have its own 10. The 11th execution for warehouse A waits in line until one finishes. The database pool stays happy. And the parallelism is per warehouse, not global. So a busy warehouse doesn't starve out a quiet one. That's the difference between concurrency with keys and a global semaphore. What you've stopped building is the connection pool gatekeeper, the per tenant fairness logic, and the deadlock recovery. It's all gone. Now, something to call out. Throttle and concurrency often get mixed up. Throttle is about rate, where that's how many runs per unit of time. Concurrency is about parallelism, how many runs at the same moment. So, different problems, different tools. Shopify sends webhooks aggressively. So when a customer edits their cart, Shopify might fire the order.updated 5, 6, 8 times in 30 seconds. You don't want to rerun the whole fulfillment pipeline 8 times for one order. What you do is you want to run it once after a customer is done editing. So we debounce. A 30-second debounce keyed by an order ID. The platform holds the function. Every new event for the same order resets that 30-second clock. When the 30 seconds passes with no new events, the function then fires once with the last event's data. Now, I do want to make a quick distinction. This is not the same as batching. Debounce throws away the intermediate events, so only the last one's data is used. And now, if you want to process the event in a burst together, that's batching, not debounce. Different tool, different problem. Debounce says, I only care about the final state. Batching says, I want them all processed together. What you've stopped building is the burst buffer, the timer state, the is everyone done editing logic. All of that gone. At least once delivery is a feature in every reliable event system, including Inngest, including Stripe, including Shopify. It means that every event can arrive twice, or sometimes more. When your event runs twice on the same payment, that's when you double charge the customer. So we dedupe. Idempotency is keyed by the payment ID. The first time you see the given payment ID, we run. Every subsequent event with the same payment ID within the dedupe window is dropped. So no second run, no double charging. One constraint. The dedupe window is for 24 hours. If you need exactly once for longer than that, a renewal that maybe fires once a month, store that idempotency key in your own database and check before processing. Same function, 4 steps inside. But now we've got rate limiting, we've got parallelism, we've got burst consolidation, and dedupe, all in 5 lines of config. We've seen customers hit all 4 of these in the same weekend. Think about Black Friday. Black Friday tends to surface every one of them. This stack is what keeps all those pipelines alive. The function didn't change, and that's the point. Before you stack all 4 of these into every function, here's when not to reach for each. Throttle. Don't use throttle if you need to fix a slow function. It just delays the problem. Fix the function first. Concurrency. Don't click a global limit when a keyed limit would do. A global cap means one busy tenant starves out all others. Debounce. Don't use it when you need data from every event in a burst. If you use a click save 5 times and each click has different content, Debounce throws away 4 of them. And lastly, idempotency. Don't use it across the 24-hour window if the same payment ID could legitimately reappear after that. It's rare, but think about renewals. If you like this, hit that like and subscribe button. And all the code, the patterns page, and docs for Throttle, Concurrency, Debounce, and Idempotency are linked in the description down below. Thanks for watching, and tell your agents I said hi.